So this is your unit 3, na?
हाँ.
We have these things. This is for brute force technique. Okay. Now, what is brute force technique? See, in unit 1, I have seen that unit 1, they have an introduction. They discussed what is brute force technique and what are other algorithm techniques. Okay. And what is algorithm, what is array, what is data structure, the relation between algorithm and data structure. So unit 1 is basically an introductory unit was there. So after that, in second unit, in both the PPTs, means the pre-recorded, they have discussed with time complexity analysis and space complexity analysis.
That which we have discussed already.
That we have discussed already with
हाँ.
that asymptotic notation. But I
Hmm.
think we should discuss some more. Okay. Although in the PPT, if you go with our previous video, that will be enough to understand the PPTs, PPT 1 and PPT 2. But
Okay.
as I saw in CA 1 and CA 2,
हाँ.
I found many things that demand to understand the time complexity analysis, especially the time complexity analysis to know more how to calculate the complexity analysis for different types of algorithm. Okay, that you have to understand. If you remember, you can, if you remember in CA1 and CA2, you have some questions like that. Find the time complexity of the following code. So they gave a small piece of code, and from that code you have to find what will be the time complexity of that respective code. Okay, so there are a number of questions in CA1 and CA2, and I hope that will also be the case in CA3
A3.
and in our final exam. So I
Yes.
think discussion on unit 2, not specially on unit 2, but especially on how to calculate the complexity analysis, especially the time complexity analysis for any type of algorithm, means
हम
recursive.
एक बार ऐसे कर सकते हैं क्या, ये CA1 और CA2 का आंसर्स कल हम डिस्कस करें क्या, ये इसका?
CO1,
नहीं तो आज
CO2
ही
ka
स्टार्ट
answers,
करेंगे.
yeah, obviously we can discuss it, but as we did in our last semester, we will discuss it after the stipulated date over.
ओके फाइन.
So we will discuss all those things, no problem.
ओके.
But we will have a discussion on the analysis of algo, how to calculate the complexity analysis for any type of algorithm that we need to know more
ओके.
precisely. Okay, that we will, I hope, means I feel that that will be needed. Okay,
ओके.
for exam purpose. But
यस वी
today
विल डू
we will start this unit,
विथ यूनिट 3.
brute
ओके
force
फाइन.
technique, and let's see whether we can complete it within 1 hour.
ओके.
Okay. Okay. So meaning of brute force approach. Basically, what is a brute force approach? Brute force approach is nothing but the simplest one of solving a problem, solving any problem.
ओके.
28. Why it is 28? Akash. Hold on. 26. हाँ 25 का बस 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 सब एक ठंडा का बंद कर दो. So brute force technique is the simplest one for all algorithm types. It tells you that you will find the solution in every possible way. Means
ओके.
all the ways you have to measure, then take a solution. That is a brute force technique. Okay.
ओके.
So suppose to make you understand, mm, say these are 2 points. You
Hmm.
want to reach from this point to this point,
Hmm.
and there are number of ways to reach to this point. Okay, there are
Okay.
number of ways, maybe path, maybe roads, or types of traveling.
Hmm.
So you want to find a path to reach to that location.
Hmm.
That will be your solution. Now, how can you find that path? You have to travel to all
Try all
two
the.
possible ways. Okay,
Hmm.
that is your brute force technique. Nothing else. It's the simplest one. Okay, and
Hmm.
in most of cases, this technique is not applied because we always want efficiency. No, we
Hmm.
always want a efficient solution, and in most of the
Hmm.
cases this will not give you the most efficient solution, but it will obviously give you one solution. If you are not able to find any efficient solution for a problem, then ultimately
Hmm.
what you will have, you will have the brute force technique. Just go for every possibility and take one route.
Okay.
That is called brute
And
force
check
technique.
which is suitable. Okay.
Yeah. Okay. So, applying brute force technique, you can say that we find a feasible solution, not the best solution.
Okay.
We find a
Okay.
feasible solution. You understand the term feasible
Okay.
means
Yes. Yes.
solution. Okay.
Yes.
Okay. So these are the examples of some algorithms which can be
Hmm.
where
Applied.
brute force technique can be applied. These are some
Hmm.
problems. These are some algorithms where brute force technique can be applied.
Hmm.
Okay. So selection sort. Selection sort is one problem where brute force technique can be applied. So they are taking this stream to apply selection sort. Selection sort is basically, uh, you know, just a minute. Do you know what is selection sort?
Yes. Yes. I know.
Yeah.
तो किसी एक एलिमेंट को चूज करते हैं और सारे एलिमेंट के साथ मैच करते जाते हैं कंप्लीटली लूप कि ये कंपेयर करके इंटरचेंज करते हैं
हाँ,
एक एलिमेंट को
just I am showing it here in that way. See, if this is our array or list, okay, we have to sort it in a selection sort manner.
असेंडिंग
Okay,
ओके
then what you will do? Simply, I'm not going with the algorithm that is given here. Okay, I'm just telling you it's the simplest approach of sorting an element, sorting a list of element. It's just like that. You have to compare it with this one. See, we will use two types of notation. One is this one and another is this one. Okay. Okay. So this is swapping or interchange and this is simply comparing. Okay. You just follow.
ओके
You have to compare with this one.
ओके
Okay. If the letter is smaller, then you interchange it. Okay. Then you interchange it. Okay. Now tell me,
यस
with this comparison, 89 is uh, greater than 45, means 45 the latter one is smaller na.
यस
So if latter one is smaller, so what I told you, interchange it.
टू इंटरचेंज
So if you interchange it, then it will become like that, right?
45 and 89 yes
Just see how simple it is. Then we have 68, 90, 29, 30, sorry, 34 and 17, right?
34 and 17 yes
Now you hold that place, this place
hmm.
is under examination.
Mm.
So now compare it with the next one. If the latter one
Mm.
is smaller, then interchange. Now tell me, is it smaller than 45?
Yes. No, no, no. It is
No,
not.
it is not smaller.
So
Then
it will not do any changes.
okay, then compare it with this one. Okay, 45
Mm.
is means 90 is less than 45. Is it the latter
Is
one is
not
smaller?
greater than that.
Is no. Then again compare it with this one. This one is your 29.
45 is lesser. So no changes.
No, why? 29. This is 29.
Mm.
29 is less than means latter is smaller
29
than
it will do.
this one.
Yes.
So here there will be a interchange. Now,
Interchange. Yes.
so just do it. 29, then
89,
89,
68,
68,
90,
90,
45,
45,
34,
34,
17.
17. Right.
Hmm.
Now you hold that place. Again, start comparing where with this one. Is the latter one is less than this one?
Yeah,
No.
no.
Then compare it with the last one. 17
Hmm.
means this is the latter one.
Yes. So 17 interchange.
17 is less than this one. So
In,
again there will be an
hmm.
interchange. Okay. So 17 will come here. 89, 68, 90, 45,
45, 34, 29.
34 and
29.
29. See here. This is called a pass. This is called a pass. And after the end of one pass, pass 1,
Hmm.
you have the
Hmm.
smallest number at its own place.
To
Now,
be, yes.
you got it.
Yes.
So this is your selection shot. Just
Hmm.
1 minute. I am just copying it and place it here. So now our task is to sort the remaining element. So how can I do it?
Hmm.
You have to consider this place now.
Second position I have to hold.
Then
Ha.
again you have to compare it with. See, 68 is smaller than 89. So you replace
Hmm.
68 here and 89 here. In this way you have to go. Okay, this will be your pass 2. Pass 2. So in selection sort, our motto is to consider one place. Okay,
Hmm.
either the either you can start from this place or you can start from this place. Okay, if you take this
Hmm.
place, then your motto will be to find the maximum number of all the element to place at this place. If you consider the first place, then you have to then your consideration will be to find the minimum number which can be put here. Okay, after that you will put the next minimum number here. Okay, so
Hmm.
for that purpose we are comparing, our comparison pattern is like that. Okay,
Hmm.
we are we are why this is called selection sort? We are actually selecting the position. Okay,
One element.
this
Yes.
position is
Hmm.
been selected and we are trying to find the number for this position. We are
Hmm.
trying to find the number from the remaining elements for this position. So what we are doing, we are
Hmm.
actually selecting one place, selecting a place
Hmm.
for which we are finding the
Yes.
elements. So this will be the pattern. Okay. So what will be the code?
Okay.
The simplest code of selection sort is something like that. For say if you start I, if we consider that the first element will be your 0, then this will be your 1, 2, 3, 4, 5, 6. Means we are considering the lower bound as 0. Okay, C style. Then your I will be start
Yes.
from 0 and
Less than or equal to n. Less than n.
less than or equal to, if this is your n, what will be n? N will be 7 because you have 7
Hmm.
values,
7 elements.
7 elements. Okay. So I will be, how far I will go? I
I
will,
will go till 7.
no, I will go to this part, this much. I will move to this place. Okay. Because
Okay.
see, for the last element, okay, you are selecting
Hmm.
this place, na? You are selecting this
Hmm.
place. And with whom you are comparing? You are comparing it with this one.
Okay.
So if you are going to select
So it
the
is
element
less
for
than
this
n.
place, then
Hmm.
automatically this place will be filled up with the rest element. Na? So I should move up to
Hmm.
this one, and there will be another loop inside it. Inside it, there will be another loop for j, which will start from I plus 1.
Hmm.
See, if you take this place, then your comparison start from this place. So j will start from I plus 1 and j will go up to this place. This means n minus 1. So, sorry, this will be j. J will be your n minus 1. It will be your less than equal to n minus 2, you can say. N minus 2 means here up to. Okay,
Okay.
both will increment by 1, I plus plus and j plus plus. So this is the simplest formula. Look, and inside that, as I said to you, say A will be the array name. So AI, sorry, you are checking if AI, AI means what? AI means the
That position.
first.
Zeroth position.
If
Hmm.
AI is greater than
Greater than
AJ, means AJ means what? The letter.
A of j. That is the next position.
Hmm. So if the first one is greater than the second one, then obviously the interchange will take place now.
So swapping.
So swapping.
Temp is equal to.
I can write like that, swapping, because it is an algorithm. So I can use the thing there.
Okay.
Okay.
Comparison could be used.
And that's
Okay.
all. This is
Okay.
your mm, uh,
Pseudocode.
pseudocode or algorithm, whatever you can say, you may
Hmm.
say. So this is your selection shot. Okay. Okay. Mm, what they are using here, the same I is equal to 0 to n minus 2. They
Hmm.
are taking mean.
Hmm.
Okay, no problem.
They are
This
every time
algorithm,
comparing with min.
and this algorithm are same. Only difference is here, whenever this becomes true, we are making swap.
Interchanging.
Okay, and I did this to make it simple. Okay, otherwise, if you are taking the mean, then what they are actually trying to say here, see, they are, I told you, if this is your smaller, the latter is smaller than
Hmm.
this one, then at once you interchange it. Okay,
Hmm.
but in this algorithm, they are not interchanging it. They are actually holding the place in some variable called mean.
Hmm.
Okay, after that, it is start comparison of this element with the rest of the element. Okay,
Yes.
so at the end of pass one, it will find this one is the minimum one, and they are
Hmm.
performing the swap at n. See here, the swapping is performed after this for loop. Okay,
Hmm.
so this for loop is actually finding the index of the minimum element in the array. Once they are
Yes.
getting the minimum element, they are interchanging it with ith. I means the first one.
Ith
Then ith
position.
0, 1,
Hmm.
2. So basically both
Hmm.
both algorithm are same, no problem. Okay, you can take any one. Okay, so
Hmm.
this is your selection shot. Okay, you got the thing,
Okay.
selection shot, how to perform.
Yes, 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 yes.
Okay, what you will
Yes,
do,
I got.
you will try to sort the complete array by hand. Means as I
Hmm.
show you here, just like that. You just
Hmm.
go on, proceed the thing in pen and paper. Okay, then you can understand
Okay.
properly. Okay. Next, the analysis of algo. This part I told you.
Hmm.
For this part, we did this thing in our
Hmm.
previous videos where we where
Yes,
we
yes.
discussed
I
with.
remember this with the examples.
Hmm, hmm, hmm. But this thing need to be discussed more for different types of algo. Now, what they are,
Hmm.
how they are actually mm, uh, do this.
Hmm.
See here, uh, if you perform this analysis on this algo, okay,
Hmm.
and on this algo, both will be same. Okay,
Hmm.
so I'm just telling you that.
Okay.
Okay, just copy it. See here. This is a loop, na?
Yes.
So how many times this loop will iterate? This will
0 to n minus 2 means 0 to 5.
huh. How to compute
N
the means this will iterate for some times. Okay,
n.
and this loop will iterate for some times. Okay,
Yes.
so what is the actual execution? This will be the actual execution. This one. Okay, maybe you consider this one also. Okay, just see. This one will,
Will
what is the
take time.
innermost means the statement. This one is the innermost statement. Okay, this if condition.
Hmm.
So how many times this if condition will take place?
That is for inner loop. How many times will take? Say, for example, here 6 times means 6n
Mhm.
into the outer loop is 5 times means into 5. Totally 30 times we can
In
consider.
that way. So but look
Hmm.
at the for statement. So can I say that
Okay.
this statement will iterate for mm, total j is equal to I plus 1
Oh, this in the summation type we were writing it, na?
to
I,
n minus 1.
huh.
Okay. For each
Hmm.
statement, here, how many statement are there? Only one statement.
Hmm.
Because this is, you can ignore altogether, ignore this one. Because this statement will not execute for each time. Na?
Hmm.
This statement will execute only when this condition will
Condition is being
true.
true.
But this condition checking will be done for every time.
Yes.
So our consideration should be for this statement, not this statement. Okay. So how many times this if condition will be checked? This much of time. If we take that each time this condition is taking place, 1 unit of time is elapsed. Then how many times it will elapsed for this one? So this is the number, na? Is it okay?
Yeah.
Okay. Now this one is inside another loop. Okay. So how many times? Then the total one will be iterate.
Yes.
Will be sum of what? I is equal
Sum
to
of I equal to
0
0,
to
I
n minus
minus 2.
2. We are ignoring this statement and this statement. Okay.
Okay.
Because this statement will, we can clearly from this algorithm, we can clearly identify that this if statement is the statement which is going to execute for more number of times.
Mm.
So we have to calculate how many number of times this statement will be executed, and that will be the time complexity of this algorithm. Okay, is it okay?
Mm.
Then
Yes, yes.
what will be the time complexity? It will be that sum of I is equal to 0 to, why I am writing I is equal to 0 to n minus 1, you can understand, because the
Yes.
loop boundary
It's
condition is this,
executing from
multiplied j is equal to, see the loop condition, j is equal to I plus 1 to n minus 1, and we are taking, why we are taking 1 is the one element, because
mm,
we are having one element. If you have 2 3 4 elements inside this loop, okay, then you
mm.
probably you will write 3 here. Okay, if you
Okay.
have 2 elements, not
Then
like
2.
this, not the statement like this which is under if. Okay,
Mm.
maybe you have some separate statement here, maybe you have some separate another statement here, some print statement, some calculation statement. Then you have to consider that if
Mm.
you have 3 lines which individually will
What
execute,
about if SOP is there? If it is printable statement is there, that also we will consider.
that also be considered. Then you have to write here 3.
Okay,
Okay,
as a different element while
yeah,
counting.
different statement that are surely will be executed inside the loop, that you have to
Mm.
consider. But later you will know that
Okay.
how many numbers you consider. Means suppose here you are getting 10 statement that will execute inside the innermost for loop, so you consider 10. Okay, you consider 10. So later
Mm.
you will find that if you consider 10, if you consider 1, if you consider 2, it will affect, it will put no effect on calculating the actual time complexity. We will see it later. Just first evaluate it. How
Okay.
can we evaluate it?
Okay.
So we have to go from inner to outer part. Okay.
Yes.
First we have to
Mm.
expand the innermost summation,
Mm.
0 to n minus 1, n minus 2. So
Mm.
if you expand this one, then what it will be? It will be
Mm.
your upper bound minus lower bound plus 1. This is the formula. What is the formula?
Okay.
Expanding the summation.
Upper one.
Upper bound
Mm.
is what? N minus 1.
Lower
Minus 1.
one.
Lower bound is what? I plus 1. Na?
I plus 1.
I plus 1
Plus 1.
plus 1. So this is simply a formula. Nothing else. Upper bound minus lower bound plus 1. So I is equal to 0 to n minus 2. So what will be there? N minus 1 minus I minus 1 and plus 1. No?
Hmm.
So plus 1 and minus 1 is cancelled. Then what we have? Sum of I is equal to 0 to n minus 2. So n minus I minus 1. Okay.
Okay.
Now, how can you expand it? See what it is saying. It is the sum of all these number from I is equal to 0 to n minus 2. Na?
Hmm.
So how can you calculate it? N minus 0 minus 1. This will be your first term.
Hello.
Hello, hello.
Hmm. Okay.
So you are putting I is equal to 0 because you have to go from I is equal to 0 to n minus 2. Okay. So you
Okay.
place
Yes.
0 here. Then plus. What will be the next term? I minus 1
1,
minus 1. Then what will be the next term?
2,
N minus 2 minus 1.
minus 1,
Then what will be the next term?
n
N
minus 3,
minus 3 minus 1
minus 1,
plus
plus
dot.
minus n,
What will be the last term?
n
N
plus 1.
minus 2.
Okay, n minus 2.
So n minus of n minus 2. Minus of n minus 2 means n plus 2.
Hmm.
Then minus 1.
Minus 1.
Are you getting the thing?
Yes.
Okay. This minus 1 is this one, na?
Yes.
This one, this
According
one.
to the formula.
So just
The
see what
third
it
term.
appears. N minus 1
n
plus
plus n
n
minus
minus
2,
2
n
plus
minus 3,
n minus 3
n minus 4, plus n
plus
minus
dot
up to
dot dot dot. What is it? N cancel,
and get is
plus 1 minus
cancelled,
1. So it will
plus
be
2,
1.
5 plus 1 will be there.
So if this is 1, then we can understand that the previous term will also be 2. Are you getting the thing? If it is 1, the last term is 1.
Hmm.
Okay, then what will be the previous term?
It will be 2.
What will be the second last term? Third
Third,
last term?
3, 3
3. So 3 plus 2 plus
plus
1.
1.
Now you can tell me how it is possible. It is surely possible because you can see the pattern. It is n minus 1, it is n minus 2, means it is
Hmm.
decrementing just by 1. Na?
Yes,
From this term, it is decremented by 1 to get the next term.
yes,
So here, from this term, if we decrement by 1, we will get the next term.
yes.
That's why we can say that if 1 is the last term, then 2, 3 will be the respective term.
Previous respective term.
Okay.
Hmm.
So in mathematics, you can say this is arithmetic progression. You probably
Hmm.
have heard the term AP series, GP series, something like that.
Yeah, it
Arithmetic
is there.
progression.
Arithmetic progression, AP.
Yeah, AP. Okay. If you reverse it, then it will look something like that. 1 plus 2 plus 3 plus
Plus
4
3 plus,
plus
it goes on up to n
up to,
plus n minus 1.
we can say n minus 1, up to n minus 1.
Hmm.
Okay. Now clearly you can see that this is the sum of all natural numbers. Okay. Sum of all
Yes,
natural numbers up to n.
n.
Here the value of n is, so what is our formula?
Natural numbers, huh?
Sum of all natural numbers.
n into
N into
n plus 1 by n
n
or 2.
plus 1 by 2.
Yes.
Okay. But here our n, value of our n is n minus 1. So what will
n
be the
minus
value?
1.
So replace this n by n minus 1.
N with n minus 1. This n also should be n minus 1 plus 1
Inside that it will be also n minus 1 plus 1
plus 1 by 2.
by 2. So what it become? This will
Now it
become
becomes simply
n into n
n.
minus 1 by
Uh,
2. Na?
it will be n.
I'm just writing this n before. N
Uh,
into n minus 1 by 2.
that's what.
Okay.
Mm.
So this is the time complexity of this algorithm. This is how you can compute the complexity of any algorithm. Okay.
Mm.
Now this is your n square half of n square
N square.
minus n, right?
Mm.
Now you have to remember something from our previous classes. Okay, algorithm. Okay, class 2, 3, where we calculate, where we learn the asymptotic notation and order. Okay, rate of growth. Okay,
Mm.
now there we already said that any constant value can be ignored. So this is equivalent to, in order to calculate the time complexity with big O notation or any asymptotic notation, we can cancel out the constant value.
Mm.
So we can write it n square minus n. This constant value will not put any effect on the total time taken. Okay, why
Mm.
we have already discussed. Okay, now
Mm.
this can also be reduced to n square. Why? Because in this two term, okay, the biggest term is what? This n square.
It's n square.
Okay, the as the value of n increases, so what term will get increased more rapidly? This n square.
It does. N square.
N square. Suppose
So the
the value
remaining
of
thing could be ignored. Yes.
the value of n is 2, then this will be 4 and this will be your 2.
2.
Suppose the value if it is 2 and the value of n is 2, this is 4, this is 2. If the value of n is 10, then this will be your 100
It's
and this will be
100
your
and it
10.
will be a 10.
If value of n is 100, then this will be your 10,000, right? But
And
this
this will
will
be
be a 100. So you
100.
can see the rapid growth in the this term. Okay,
Mm.
and moreover, this is actually subtracting the value. So
Mm.
this much value, if you subtract this much value from 10,000, it will affect
It will not have any great effect.
great effect. Okay, so it will not have any great effect. So we always consider the
Mm.
greater term. That's
Greater
why
term.
we come to here. And this you have to put inside big O notation.
Big O notation.
This is the concept of rate of growth. And this we call the time complexity of this respective algorithm. Okay.
Mm.
So the time complexity for selection sort algorithm, this algorithm both are same. See here the range I is equal to 0 to n minus 2. This is also I plus 1 to n minus 1. The same will take place. Okay. So this is the way how you have to calculate the time complexity of selection sort. Tell me if it is okay. Hello.
सॉरी मेरा इंटरनेट थोड़ा डिस्टर्ब हो गया था कनेक्शन.
Okay, okay. Tell me if it is okay.
It is fine.
Okay. So next we have bubble sort. Acha, bubble sort is something similar to selection sort. The same means the calculation. The
Mm.
calculation will remain same.
Mm.
There will be no change. Okay.
Mm-hmm.
Analysis of bubble sort. The process is something different, which I can quickly describe here.
Okay.
Suppose we are taking the same array.
Mm.
The pattern of bubble sort
Mm.
is different from selection sort. As far the efficiency is concerned, both sorting algorithm has the same efficiency. Okay, means
Okay, okay.
uh, you can
As a
use
selection
bubble
sort.
sort or selection sort.
Mm.
Both will work same for you. Okay.
Mm.
Now see here, bubble sort.
Mm.
We can take two approaches from left to right or right to left.
Mm.
Here I am taking this approach from right to left. So we are finding the value for this position. Now tell me which value will sit here. The maximum number means the
Mm.
largest number will sit here. Na?
Huh.
So how can we find the largest number? We have to find the largest number and we put that largest number here. Okay. For the
Mm.
rest of the number, we will find the largest number and we put here. After
Mm.
that, we will discard that part and we will again find the next largest number and we will put it here. Then we will
Mm.
discard that place. Are you getting
Yes.
the logic?
Yes, 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 I got it.
Okay. Then how can we proceed? We can proceed in that way. See, always remember this is bubble sort. This is your selection sort. Okay. Selection sort, linear sort.
Mm.
Linear sort तो ये भी है, but selection sort there is another name some author use simple sort. So bubble
Mm.
sort in bubble sort you have to compare pairwise.
Okay.
You have to remember this thing pairwise, and
Okay.
you will remember surely. Pairwise comparison is done.
Mm.
Pairwise means you have to compare
I got
these
it.
two.
This one.
If the in selection sort I told you that if the latter one is smaller, then make a swap. Here I am
Mm.
telling you if the first one is bigger,
Mm.
then make a swap.
Okay.
मतलब हम लोगों का मोटो ये है, देखिए ये तो 89 है ना,
Mm.
so this is the maximum of most of the items. Okay,
Yes.
so we will push this maximum number towards this end
Mm.
until we get more number, means the larger number than this number, we will push it
We keep
in the
shifting,
right direction.
swapping the numbers towards the right.
See, here you can clearly see that 89 can be pushed up to this place. Na?
Yes.
After
Up
that,
to
it
the
will get
second class.
90, which is
Mm.
more than 89. Then we will start pushing this 90 in the right direction and we will
Mm.
reach to this place.
Mm.
This is the logic. Okay.
Okay.
So now see, the first one is greater than the second one. So we will make swap. Instantly we will make swap. So
Mm.
you will have 45 here, 89, 68, 90, 29, 34, 17. What we are doing? We are going one pass. After that, what
Okay.
we will do? See, in
We will.
selection sort, we were taking the concept like that. Okay.
Mm.
Here, we will take this pairwise, means we will compare now this one, because 89 is your largest number till now.
Mm.
89 is your largest number. You till now you have compared two numbers. So among the two
Okay.
numbers, 89 is the largest number. So you cannot leave that position. You cannot leave
Yes,
that
you
number.
cannot
To
leave
leave
that
that
position.
number, you have to start comparing with the next number. Okay.
Mm.
So here again there will be a swap. So 45, 68,
68, 89.
89, 90, 29, 34, and 17. So
Mm.
don't leave 89. Okay. So compare
Mm.
it with the next one. Okay,
Mm.
sorry. Here I have to make
Put that
no swap.
swapping symbol. Mm.
Now here see, there will be no
Mm.
comparison. There will be no swap because 89, the first one, is not more
It
than the
is,
next one, second one.
yes. So
So
89 will be like that only.
that time the algorithm will understand, okay, we got something more than 89.
Okay.
Now leave 89. Hold
Position will be
90.
swapped
If we hold 90, then we have to compare it just
with the
the
next
next number,
element. Mm.
pairwise. So here clearly there will be a swap. So 45,
Mm.
68, 89, 29, 90, 34,
34,
and 17.
17.
Don't leave the 90.
Mm.
Hold 90 and start comparing with the next one. Again there will be a swap.
45, 68,
45,
89.
34, 90, 17.
Mm.
Don't leave 90.
Mm.
So again there will be a swap. So up to this will be your 17 and this will be your 90. Got it? See
Yes.
here. 90 got its place. Here complete pass 1. This is the
Mm.
pass 1. Pass 1.
Mm.
As the pass 1 completed, we got the largest number and we placed it
In the rightmost side.
at its own position. Okay.
Mm.
Now we have to leave that place. We have to leave
Mm.
this place. Now we will start again
From 45.
from 45. Then again we will do the same thing.
Mm.
So in bubble sort, our pattern will be like this. Okay, pairwise comparison. This is your
Okay.
bubble sort. This is your bubble sort, and this will be your selection sort. There, the pattern of the two sorting algorithm is like that. Okay,
Okay.
see, I is equal to 0 to n minus 2. Then j is equal to 0 to n minus 2 minus I. And what they are actually comparing, look here, j plus 1 and j.
Mm.
What are the two elements? The two elements are
18. In this example, if I consider, then 45 and 89.
means from this statement we can tell that jth element is compared with the next element, j plus
Next
1th
element.
element. Huh?
Mm.
What is this? So this is your pairwise comparison. Okay,
Okay.
so we can write another means not another algorithm. The same algorithm can be written like that. So in simpler term, we can write this algorithm as, say, for I is equal to 0 to, sorry, ऐसा करो, I is equal to n minus 1 to I greater than or
0.
equal to 0,
Equal to 0.
I minus B.
I minus minus.
For j is equal to 0, j loop will start from 0 and j will go up to less
I.
than equal to I. Okay, we go up to I.
J plus
See, the
plus.
value of I is n minus 1. So it will be the last value, last position.
Last value.
After
J
that,
plus plus.
j will, I will be decremented by 1. So the second last position. So this loop will iterate up to second last position, na? J plus plus.
Hmm.
Inside this, if a of j means the first one, if it is greater than a of
Hmm.
j plus
Is
1
greater than A of J plus 1.
means the next one. If the first one is greater
Hmm.
than the second one, then what you will do? You will perform
Then
swap.
swap it.
Aj,
A of I
not I. A of j
interchange
with
with
a
A
of j
of J.
plus 1.
Okay, okay, correct, correct. A of
Okay.
J
We do not use
has
the
to be
I
interchanged.
here for
Yes,
comparison.
yes.
We are using I for the
Comparison method. It is
position,
only for
last position,
pass.
to determine the last position.
Hmm.
Okay. So the algorithm can be written in this way also. Okay.
Yeah, this looks
Without
more simple.
without going to any complex thing, this can be written very simple. Okay. So your bubble shot is done, I hope.
Hmm.
Analysis of bubble shot is same like selection shot. You will understand.
Hmm.
Okay. Then you have sequential search and linear search. In fact, this is the simplest one. Means you have to find value in an array.
Hmm.
Should I explain it or it is?
No, this I am done with. I can just tell you the gist of it. Just we are keeping the first element as a linear element for the as an array element to be
Hmm.
searched and start comparing with the rest of the array elements. If it is finding, then sorting means searching will be
Yeah, yeah,
completed. Else, it is not element is not found.
yeah. Ekdam.
Correct, na?
Huh. Very simple.
Uh,
You are starting a loop from 1 to n. If it is
1 to
matched,
n travels
then
in
return
through
the
all the
position.
elements.
Otherwise,
Yes.
return minus 1. Minus 1 cannot be any place in the list. That's why
So it
if we
is
receive minus 1,
search
we
not
will
found.
understand that the search is unsuccessful. Okay.
Mm.
Okay. Now here they are saying something linear efficiency. They are trying to calculate the efficiency. In most of the cases, the worst case, best case, and average case has been understand by this algorithm, this searching linear search algorithm, because this is the simplest one. Worst case
Mm.
efficiency. So we have three cases in calculating
Mm-hmm.
the efficiency of an algorithm. Okay.
Mm.
Worst case, best case, and average case. Now, what is this? What is worst case? Best case. Now, first we identify what is best case. Suppose you are going to find an element in an array and
Mm.
you are lucky enough to find it in the first place. So
Okay.
how many iteration or how many checking you have to perform?
Mm.
Tell
It
me.
will be very less. Only one.
Only one, not less. It is only one.
Mm. Only one.
This is called best case. Okay.
Mm.
This is called best case. Means if
Mm.
you are getting the solution at
Mm.
the most minimum amount of time, that is best case. Okay. The smallest number of working the algorithm need to perform. Okay, so that is called base case. So obviously, what will be the worst case? if you are finding the element at the last place,
Last,
at the last place,
last place.
when you are finding the element at the last
Mm.
place, then you have to perform all
Mm.
this, then you have to go all this loop, means the loop will iterate for the maximum number of time, right?
Mm.
Because the element is at the
Mm.
last position, so the loop has to be
Mm.
completed fully from I is equal to 1 to n. So that is the worst case. Somebody may
Mm.
understand that worst case means we are not finding the element in it. It is not the case.
Mm.
Worst case means you are finding the
It is
element,
at the last
but it
position.
is at the last position.
Mm.
So that is the
Mm.
worst case. So best case, worst case, and average case are not something like that. We are not finding the solution. We are
Mm.
finding the
We are
solution.
finding, but it
What
is
is the
taking time.
minimum number of time? What is the maximum number of time? And what is the average number of time?
Mm.
Okay. So not finding the element is means not finding any solution is something different. It's not the
Mm.
case. So average case is means
Somewhere
average
in the
case is
average time.
between worst case and best case. Okay.
Best case.
So you see, best case the time complexity is omega of 1. You can say big O of 1 also.
Mm.
You remember what is omega, what is theta, and what is big O?
Yes, yes.
Omega was the what? Big O is what? Big O is upper bound. Omega is
Upper
lower
bound.
bound, and theta is both upper
Mm.
bound as well as lower bound. Okay. That's why I am not discussing that algorithm.
No problem. I will.
You just go through
I'll
that.
take it once again, that one, and
Then,
I will.
then we will take some algorithm example how to calculate the
Mm.
time complexity of different types of algorithm. We will definitely do. That
Okay.
is required for example.
Mm.
Okay, so see, you consider currently this considered as big O. Big omega, big O are same. Okay,
Mm.
you can represent the time complexity or space complexity by any
But
term.
why here they told for best case unsuccessful search?
Hmm. Best case unsuccessful successful search. Why it is big O of 1? Because you are getting it at the very first time, means the constant amount of time will be required. Okay, so suppose
Unsuccessful search?
answer, I am telling you answer, but before you have unsuccessful search, you understand what is successful search. So why it is big O of 1?
Okay.
It is big O of
Mm.
1 means big O of 1 represents constant time. Means if the element that you are looking for, if it present in the first position of any array,
Uh,
then whatever be the length of the array, it doesn't matter. You will get always
100%. We will get the searching the element in the first attempt itself.
first attempt. Okay. So your algorithm may take different times at different computer in different computers.
Mm.
But the thing is that you will always get it in the constant amount of time.
Mm.
Okay. So it is not dependent on n. Okay.
Mm.
That's why you will say that we are saying that this is a constant amount of time. Big O, big omega, or big theta, anything. Okay.
Mm.
Now, what is unsuccessful search? Suppose you are not finding the element anywhere in the array. Then what will happen? The
The
thing,
time what?
the thing is that you have to go through the array. Means you have to
Yes.
move to this loop completely.
Mm.
If you iterate this loop completely, then how many times this operation will take place? N times.
Mm.
So if the search is unsuccessful, then
Mm.
what will be the amount of time required
Okay,
to know
consumed for
that
to
the search is
traverse the
unsuccessful?
array. Okay.
No, 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 you are not getting. Unsuccessful search. This is also a search. Now tell
Mm.
me, what will be the when we will know that our search is unsuccessful?
Till the end.
Till
End.
the end.
After searching the end, the last element, nth
Uh,
element.
So they are saying that best case efficiency for unsuccessful search means to know minimum amount of time. Best case means what? Minimum amount of time.
Minimum amount of
So
time.
what is the minimum amount of time you will take, this algorithm will take to declare that the search is unsuccessful? That is your big O of n. Na?
Okay, okay, okay.
So means after you go for n times, you will understand that and that is the minimum amount of time you require
Mm.
to know that the search is unsuccessful. That's why they are saying best case for unsuccessful search.
I got it. This formula. It got registered in my mind now.
Hmm. This is a tricky thing. Best case unsuccessful search.
Omega 1 means we are getting it at the first attempt only. Omega n means we are getting it at the nth place after reaching to the nth element. Is it correct?
Unsuccessful search means after nth
Searching in the last
comparison.
element only, we'll come to the conclusion. So
Yeah.
omega of n,
Omega or big O, big theta,
we go.
always same.
Okay.
Okay.
Ah, but what I'm understanding is correct, na?
Which one? Tell
This
me one more time.
1 and n, this formula. If it is for the successful search, it will be big O or omega or theta of 1.
Hmm.
If it is for unsuccessful, it will become n, right?
Unsuccessful search, it will become n.
Okay, I completely got understood this.
Hmm. Now, the average case efficiency. Now, average case efficiency means the element is not at the first position, not at the last position. It may be there
In between.
in between. Okay. So here comes the probability. You remember MFCA last semester,
Yes.
probability. So
Hmm.
if we consider P is the probability,
Hmm.
just give me 1 minute. I'm going through it.
Okay.
Let probability first. Okay, the probability ith position, number of comparison is L for successful search. What is L? Successful. What is L? The number of comparison is L for successful. Anyway,
I
leave it.
think that is IE. IE, they have written it like that.
I don't know. Anyway, leave it. See, you have an array and you are going to find an element. Okay.
Hmm.
Now we assume that P is the probability of finding that element. You got it?
Hmm.
P is the probability of finding that element in the array. Okay. Now, what will be the range of P? We know that probability ranges from 0 to 1.
Yes.
Okay. So, how many elements are there in the array? N
N
elements.
element.
So, what will be the probability of each element to find in the array? That is P by N,
Ah.
right?
Hmm.
Because the probability of finding one element from the
Out
array
of
is
P,
equal
out
for
of
every
N.
element. है ना? The probability of
Hmm.
finding an element from the array is equal for every element. If the total
Yes.
probability is P and if you have n number of elements, then what will be the probability of finding one element? P by n. It is the average because we are
In,
finding average.
yes.
Okay. So P by
Hmm.
n is the probability, average probability of finding each and every element.
Hmm.
Okay. Now consider the
Okay.
position. First position, second position, third position, up to nth position. Na?
Hmm. Hmm.
So what will be the total time of finding an element and maybe for successful search and unsuccessful search?
Hmm.
See, this is for successful search, this is for successful search, and
Hmm.
this is for unsuccessful search. How? First thing, the first position, the element at the first position.
Hmm.
Okay, what is the probability of finding the first element? It is 1 into P by
1
N.
into P by N.
What is the probability of finding the second element?
2 into
2
P by
into P
N.
by N. Like that. What is the probability of finding nth element?
N
N
into P
into
by
P.
N.
So the total time is the sum of all these things. Huh?
Ah.
So it is for successful search.
Hmm.
Okay. Now what is unsuccessful search? Unsuccessful search is 1 minus P.
Hmm.
1 minus P, you remember from MFCA, if P is the probability of finding an element, then what will be the probability of not finding an element? That is also a probability. That is 1
Hmm.
minus P.
Yes.
That is also a probability. Means you are you want to find a taxi, okay, a
Yes.
cab on the road. Okay.
Hmm.
So if the probability of finding the cab on the road is P, then what is the probability of not finding the cab?
P min
1
P
minus
min
P. 1
N
minus
1
P.
minus. Okay, 1.
Okay. So 1 minus P is the probability of not finding that element, means the
Hmm.
unsuccessful search. And you have n elements, total n elements. So what is the total probability of not finding an element in the array? That is n into
N
1
into 1
minus P.
1 minus P.
See, this is the total number of search, and this is also the total number of search. So what will be our total number of search or the operation? This is the sum of both. Okay.
Mm-hmm.
So if you are calculating, if you take common this P by N, so what it
Mm.
remains? Sum of
1,
natural
2,
number.
3 billion.
Sum of natural number.
Mm. And
See,
that is
sum
again the
of natural
formula.
number.
Mm.
They missed the second, third bracket here is given. Okay. So P by N, you understand? This is sum of natural number. You
Yes,
understand?
yes, yes.
Okay. So they are taking common term कुछ ऐसा किया है इधर. And
Mm.
this n and n will be discarded. Na? This n and this n will be
Discarded.
cancelled out. Okay. So this become a simplified figure. After that, we go to the next slide. See here. So this is the average time. This is the average time. Okay.
Mm.
Now here you consider if the search is successful. Yeah, they are giving
Mm.
it. If the search is successful, then what will be the value of P? The value of P will be 1.
Mm.
If value of P is 1, then this term will be 0. 1 minus 1 will be 0. N into 0 means 0. Okay.
Mm.
If if the search is successful, then what will be the value of P?
P is 1.
P is 1. Okay. So you put P is 1 here. So what you will get?
Mm.
You will get n plus 1 by 2.
Mm.
It will be n plus 1
N
by
plus
2.
1 by 2.
So if it is n plus 1 by 2, then what will be the complexity? It is
It
big
is
O of
the
n.
success.
Big O of n, because 1 by 2, see here, the, the calculation will be what? N plus 1 by 2, na?
Huh.
So half will be
Mm. A
half
half will be
n
discarded.
plus 1, right? Half will be discarded. So
N
among
plus 1
n
will.
and 1, n is the
Mm.
maximum. So you can write
Mm.
this is big O of 1, big O of n, right?
Mm.
So what will be the complexity of linear search when the search is successful? It is big O of 1,
Search is
big O of
successful.
n.
Big O N.
Okay, in average case. See, when the search is unsuccessful, that time what will be the value of p? The value of p will be 0.
आपका आवाज थोड़ा ब्रेक हो रहा है.
Is it okay now?
हाँ.
Okay. If the search is unsuccessful, then what will be the value of p?
-1.
No, minus 1,
0, sorry, 0.
0. So just put p is equal to 0 here in
Mm.
this. So this term will be 0. This term will be 0.
Mm.
Okay.
Mm.
What will be this term? This term will be your n.
N.
So if the search is unsuccessful, then what will be the complexity? This will remain n. So it will
N.
also be your big O of n.
Mm.
So the unsuccessful search in average case for linear search algorithm is big O of n,
Mm.
and here for best case, in average case and best case, both case
Mm.
unsuccessful search will be your big O of n.
N.
Got it?
Mm.
So that is they are saying here. Tell me if it is okay.
Yeah. Everything we got right now.
Okay,
What
na?
we discussed so far. Yes, yes.
Okay. So pattern matching is we will stop here today. Okay.
Yeah.
It is
It's
already
already 10
10
seconds.
o'clock. So we will
Mm.
stop here today. If you have time, then we can
Tomorrow.
continue it tomorrow.
Yeah. Tomorrow I'll try to connect a bit early
Mhm.
so
No
that we
problem.
can.
Tomorrow I will remain free in evening, so you can call me when you are free. Then we can
Okay.
continue the
Yes.
rest of it. Okay.
Testing. Algorithm techniques will complete it.
Okay. Okay. So